BCSD third graders. It's Mrs. Truitt, and I am here to help you with our May 15th math procedural practice and our math task. So today they want us to write an addition sentence and a multiplication sentence to show equal rows. So they want us to write an addition sentence and a multiplication sentence to show equal rows. So again, we know this is an array. We know it's an array. It has rows and and columns. It has rows and columns. So this is one row, this is a second row, and this is a third row. So when I look at how many rows there are, that is the first number in my multiplication sentence. When I look at how many are in each row, so 1, 2, 3, 4 across in each row, that's my second number to my multiplication sentence. So technically what I'm doing is I'm giving 1 to each row, 1 to each row until all of them are gone, however many apples I have, and I need to have an equal amount in each column and in each row. Okay, each column and row, or else it's not an array. If there were 3 here and then 4 here and 4 here, that would not be an array. So it has to have the same amount. And see how nice and equally spaced they are. Whenever you draw your arrays, make sure they are nice and neat and there's good spacing and they line up. So we know that there are three rows, and we know that there are 1, 2, 3, 4 in each row, so there are 4 columns. All right, so now we're going to count how many are in each row. There are, of course, 1, 2, 3, 4. So I know that there are 4 in each row. There are 4 here, there are 4 here, and there are 4 here. So I can add this up as 4 plus 4 plus 4, or I can multiply it as 3 times 4. So when I add 4 plus 4, I get 8. And if I add another 4, I'm going to get 12. And 3 times 4 is the same thing. It's like adding 4 3 times. 4 plus 4 plus 4. All right, so now we're going to look at these juice boxes. We're going to do the same type of a problem here. And we're going to see how many juice boxes are how many rows of juice boxes first. So I see there are 1, 2, 3 rows of juice boxes, and I see that there are 1, 2, 3, 4, 5 in each row. So that means there are 1, 2, 3, 4, 5 columns. 3 rows and 5 columns. So if you think of it that way, your first number is the number of rows, and your second number is the number of columns or the number of juice boxes in each row. So if I know that there are 5 juice boxes in each row and there are 3 rows, I can add 5 3 times. 5 plus 5 plus 5. So 5, 10, 15. So 3 times 5 is essentially just counting by 5s 3 times. So that's going to be the same answer. 3 times 5 equals 15. All right, we're going to move on and look at the commutative property. I'm going to do 2 of these problems, and I want you to try the other 2 on your own. So we have 3 times 2 equals 6. And the commutative property of multiplication says that you can switch numbers, the factors in a multiplication problem, around, and you will get the same answer. Okay, so what it's saying is these 2 numbers can get switched and you will still get the same answer. It's kind of like a fact family, because it is a fact family. These 3 numbers can be used to write a division problem, and you can take these numbers and switch them and still get the same answer. So I know that I have a 3 here, and I have a 3 here for a factor. I have a 6 here and a 6 here for my product. So remember, the product is the answer, and these are my factors. Okay, so factors and product. So if I have 3 here and I know that 3 times 2 equals 6, then what number times 3 is going to equal 6? Well, it's just going to be a 2. I'm just going to switch those numbers around and see that regardless if it's 3 times 2 or 2 times 3, it's going to equal 6. Let's go ahead and make an array for each of these. So 3 rows, 1, 2, 3, and I'm going to give 1 to each row until I get to 6. So 1, 2, 3, 4, 5, 6. Wow, that was pretty easy. So this is 3 rows of 2, or 3 rows and 2 columns. So that would be the same as saying I have 2 plus 2 plus 2. Just like they did it up above, which equals 6. Now I can do the same thing here. I don't know how many rows yet, but I know, let's say this number wasn't here yet. I do know that there are 3 in each row, so I can go this way instead. I can count 1, 2, 3, 4, 5, 6, and I can see that there are 2 rows and that there are 3 in each row. So this would be 2 times 3. This would be 2 3s. I have 2 rows of 3s. So I would count 3 plus 3 equals 6. So both of these problems are the same answer and outcome. We're just using the commutative property. And what I taught students at school was that mom or dad might commute to work. Like my husband used to drive to Ventura on Monday. He'd come back home to Bakersfield on Thursday. So you can go from Bakersfield to Ventura and go back to Ventura to Bakersfield. So those numbers can switch around and you can still get the same answer even though it's a different multiplication sentence. You're still multiplying the same 2 factors. All right, so let's look at this one. 6 times 4, these are my factors, equals 24. All right, so that would be, if I was making that an array, that would be 1, 2, 3, 4, 5, 6, a row of 6, and I keep going. I have to do that 4 times. 7, 8, 9, 10, 11, 12, until I get to 24. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I'm giving 1 to each row. So this is 1, 2, 3, 4, 5, 6 rows, and this is 4 in each row. 6 times 4. So knowing the commutative property, I wouldn't have to really draw all this out. I'm just showing you, as they did in the problems up above, one way to solve. So 4 is in each row, and we're adding 4 6 times. So that would be 4 plus 4 plus 4 plus 4 plus 4 plus 4, which we know equals 24. Well, this is the same, except my array would look different because I'm multiplying 4 by a number to get to 24. So 4 is my number of rows, and I'm going to make rows and give 1 to each row. I'm going to give 1 to each row. I've already made 4 until I get to 24. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I see there are 4 rows, and there are 1, 2, 3, 4, 5, 6 columns, or 6 in each row. So see, this is the same. It's just the commutative property. So we're taking 6 times 4, and we're getting 24, and then we flip the factors, and we do a switcheroo. Some of my students in class would say we're doing the switcheroo, and you would switch them around, and you get 4 times 6. So 4 times 6 would be 6 plus 6 plus 6 plus 6. I know 6 plus 6 is 12, 6 plus 6 is 12, and 12 plus 12 is 24. All right, boys and girls, go on, and I'd like you to do the same here. I know it's easy peasy to figure out what that missing factor or product is, but I want you to draw your array and write your repeated addition sentence as well. All right, so continue with those problems. We're on the math task. It says Lisa put 50 paper pens in her pen box. The box has 5 rows. So 50 paper pens went into her little pen box. 50 paper pens. Okay, these are pens that you would pin onto something like a jacket or a bag. The box has 5 rows. It has 5 rows in the box. Okay, if each row has the same number of paper pens, how many pens did Lisa put on each row? So this is the same thing that we've been doing. We're taking this problem and we're making an array. So this is more looking like a division sentence because we have 50 and we are going to divide the 50 into 5 rows, 50 divided by 5. Okay, so if I make 5 rows, I have to go all the way until I get to 50. So we're going to try this. You can count with me. So we're going to do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm using the array strategy. I know that it takes a little bit of time. You can use whatever strategy works for you. This says rows, and since we had done arrays the last 2 days, that's what I'm going to work on. But it's just one way to solve the problem. You can do a different strategy if you'd like. So 6, 7, 8, 9, 10. I have a long way to go to get to 50. 11, 12, 13, 14, 15. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. We're over halfway there. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So I know my 5 here, but I need to figure out how many are in each row or how many columns there are. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 50 divided by 5 would be 10. So that would mean there are 5 rows, and we're putting 10 in each row. So we count 10, 20, 30, 40, 50. And this problem, thing about division is that you can flip it around and make it a multiplication problem. So this is the number of rows. This is how many are in each row, and this is my total. But if it was a multiplication problem, it would be 5 times 10, or 10 times 5 equals 50. So see, these numbers move to the front. Factors go to the front, and then they just move to the divisor and quotient if you make it a multiplication problem. And remember, this is our dividend. Dividend's always going to stay in the same place, and the product's always going to stay in the same place. Your big numbers at the beginning in division and at the end in multiplication. So another way to write this as a division sentence would be 50 divided by 10 equals 5. Both of these are equal. They are the same. Both of these are equal. They are the same. Just different ways to write those problems. All right, so we have to write that out as a sentence. I want you to write your sentence out here. How many pens did Lisa put on each row? Write it in a complete sentence. Okay, Edward had 5 boxes of pens. Each box had 15 pens in it. How many pens did Edward have in total? How many did he have all together in total? Okay, so he has, let's write down what we know. He has 5 boxes of pens. And he has 15 pens in each box. He has 15 pens. These are like writing pens that I have right now. In each box. So I would probably draw a picture for this. You could do the array. You can choose your strategy. You can make an array. First, you got to figure out what you're doing. What are you solving? Is this multiplication or division problem? So if I have 5 boxes, and there are 15 pens in each box, I want you to think of a strategy to solve this. What kind of a problem is this? What do I do with the 5 and the 15? All right, this one is a little bit trickier. So if you make 5 boxes and put 15 in each, you can add those up together and figure out your answer. You could make an array, 5 rows, and 15 in each row. That would be a very large array, boys and girls. That might take you a really long time. I wouldn't suggest that. I think a picture is a really good solution here. And then it says, how many pens did Edward have in total? Please write your sentence here, multiplication, division, whatever it is, and solve the problem. All right, boys and girls, I hope these videos are helping. And again, please ask me any questions. You can message me on Class Dojo. You can message me on Google Classroom. Okay? And I hope you have a fantastic weekend, and I will see you on Monday. Bye-bye.